So feasible processes, we're looking at trying to understand what does that actually mean. Here we go. So a feasible process is also known by another name, which is a spontaneous process. A spontaneous process. So a feasible process is a process that happens without a continuous input of energy. So any process that happens without you having to continually, say, heat it up, is a spontaneous process. Now, sometimes these feasible processes or spontaneous processes do require some energy to get them started. And so I'll put that here. They can require some energy to get them started. So it can be feasible even if you have to give it a bit of heating to start it off. But once you've started it, it should carry on by itself. And this is just taken from your textbook. A feasible reaction is one where the products have a lower overall energy than the reactants. So in other words, another way of saying this might be that the products are more stable. That might be a way that we would describe that. Now, when we're talking here about energy, you've met energy before. And in year 12, we called it enthalpy. So if that statement is true, which it is, can we use the enthalpy change to help us predict feasibility? Is it the case that if we have a negative enthalpy change, so where the products have a lower overall energy, that somehow that will enable us to be able to predict feasibility? So let's do a few examples to see if that's the case. Yeah, I wouldn't write these down. If you're taking notes, I'll summarize it at the end for you. So imagine I've got some water in a bottle. Here I've sealed the bottle up, so it's a closed system. Will that water evaporate? Well, the answer is no, it won't. And perhaps it's relatively easy to see if we think about the enthalpy here. If you think about the enthalpy here, then if we have water in its liquid state at the start, we're going to have to supply some energy in order to turn this into water gas and break all those wonderful hydrogen bonds. And therefore, we're going to have some kind of activation energy as well to do that. But our enthalpy change, if I put it on here, delta H there is going to be positive. So this is an endothermic reaction. And it's not feasible as we might have expected because the products have higher energy than the reactants. What about a candle burning? This is a feasible reaction. If you think about energy again, you might have to give it, well, you do have to actually light the candle. But if we think here about our reactants and products in this case, then although there's a bit of an activation energy, we are going to get a negative enthalpy change. This is an exothermic reaction. And it's a feasible reaction. So far, so good. Exothermic reactions are feasible, endothermic reactions are not. Let's try a third reaction, and you can very welcome to try this at home. This is baking soda and vinegar. And if you mix this acid together, then you start with your reactants there. You mix these together, you get a very, very quick reaction, lots of carbon dioxide given off. So these are my reactants. The problem is that when you actually measure the temperature change, you actually find that this reaction is endothermic. You'd actually find that there's a very small temperature change here, but the products do actually have slightly higher energy than the reactants. It's got a very low activation energy, but delta H is positive. So this is an endothermic feasible reaction. And there are a number of other endothermic feasible reactions, a number of substances you try to dissolve them in water, and it will be endothermic, but they are feasible reactions nevertheless. So we have these things perhaps worth summarizing. This was true. Feasible reaction is where we have lower overall energy than the reactants, but enthalpy can increase. So when we're talking about energy here, we're not talking about enthalpy. It's something else going on here. The other slight problem with this is that feasibility will depend on the temperature. Feasibility depends on temperature. So let's take our water in a bottle evaporating situation. At room temperature, this reaction will not be feasible. However, if you put the temperature in the room up to 120 degrees C, provided that you didn't have so much water in here that the pressure buildup would be too great, you would end up with water evaporating feasibly, spontaneously. It would happen. So it's a little bit more complicated. We can't just think of the enthalpy change. We have to think also about something else. So just to summarize, sharpening up our question that we had at the start, how can you decide whether or not a process is feasible or not? That's our central question. And so far we've seen that feasible reactions can be exothermic or endothermic. So we need a different quantity. We need a different quantity to predict feasibility. Enthalpy just won't cut it.